Hi to everyone. So now for today's video we are going to cut your paper. This is the insulating paper. In this video of how to wind your 1 horsepower motor, we are going to use a gauge wire of 22. We got the slottings, all will be linked in the description box below. I am going to show you every step from except I may not show you how to remove the wires from the stator, the burnt wire, but I will show you all the wire gauge which was in and the one I'm putting in, the coils, number of turn, pitch, all will be down in the box. So right now, cutting up the papers, and the paper gauge is 0.24, which is typically hard there. Then after here, I'm going to show you how you fold it in order not to slide off during the installation. This is my stator right now. Then yep, because many videos are online here, but without showing you how you fold this paper. You fold it at two sides facing you, then end up on the other opposite side by making it that way, and then slot it in. So if you watch this video from the start to the end, basically you'll be able to tell. Now after folding it, try it in. After trying it in, if it is the right length, width that you need, get it out and then make the rest. But if it is maybe too big or too small, you are able to remove it, organize the size. That's how I came in to learn about the right size which I need, because sizing is vital, not to make these papers when others are too long, when others are short, so they should look uniform, okay, as we are going to see in front there. And then if you can't manage to do it the way I'm doing it, you can get a straight roll edge, and then you mark where to carve from, because I'm doing it just out of experience and too much time put in motors. So if you can't do it the way I'm doing it, because you can see everything is in the same, let me say maybe everything is of the same height and do this. So if you want to do it the way I'm doing it here, you got to use a straight edge meter rule. You mark and then go about it safe. Now as our stator is done, this is the last slot to insulate right there. Then after insulating, you have to understand which size of the wire you're going to use. After that, you got to know the length, the pitch. So my pitch here is 1 to 5. That is 1 to 5, 1 to 6. No, sorry, 1 to 5. That is 1 to 5. Then 1 to 8, again 1 to 12. That is it all for the running coil. And this is how you can go about it, how to get those wires length. You use the burnt one to adjust on how you go about it, or you only take the starting coil, which is 1 to 5, and then the rest will be automatically given in the distance. If you're using a given tool, which I don't use, because I try to show you that even if you don't have tools, you can still do some great job and get paid. And after this process of finding the length of the slots, and the number of turn is going to be given in the description box below, which will be the from the small to the large, and from the start to the end, including the running coils with the starting coils. So this is my last running coil, and that will be my length of it. Then pick them out. So when you pick them out, using this tool, because it has a video on. I'm going to show you this video as time goes on, but I have this video ready how you can make your own tool of motor winding if at all you're interested in motors, and not forgetting to give it a thumbs up. So when you get them out, immediately after using them the way I did, so get them all. There should be 4, and the 4 of them, they should vary in length, because one wire is longer than the other, so that element brings in the shortest. Okay, if at all there are 3, if they are 4, the same manner, but they should vary in length. So these are my 4 running coils of one side. Then I have this 4 one side and the 4 the other side. So using this same length, because the starter is of a uniform length, get your 2 and then start with either the short or the long. In any way you can go about it, but for my case, I started with the short one. Sorry about this. So for my case, I started with the short one and adjust it fully to make it straight like so, and then tie the bottom nut. So when I tie the bottom nut, I'll be able to tell which length is this using a tape measure and marking right there. That is my first coil. On a tape measure, this is 5.5 inches, so I have to note it down here. So moving on, the second one, pull it, then measure. After measuring, mark and take a note, which is 6.5, meaning even if I don't measure the rest, I can go by that difference of 1. So but I will be able to measure because I want you to see. But if at all I was not showing you, you see this is 7.5, so 7.5, 5.5, 6.5, indicating that even the last one will be 8.5, because they usually take, you see that, 8.5. So they usually take the same difference of that coil. Now after we're going to wind, you can slot it on, you can put it on and then remove it when tight, and then you start winding. Or if not, you can adjust by tape and then you start winding. So any of the 2 can work. If at all you have anything where you can rest your wire, that is okay. But if you don't have, I always recommend you to do as I did here. You get a bottle and place it in between, then the wire will automatically move up where you're winding from easily. Then besides that, I always give tips during my works. Then the next thing to do here is being stable, because if at all you're not stable, actually even someone can come in and just say, "Hi, engineer." So from that point you will forget how many turns you were on. So and you don't have the counter. I have it, but I don't want to use it in the video because you may think that without the counter you can't do the motor winding. Please, no. Then another thing is you have to isolate from people, because they may interact with you, damage the coil that you are slotting in, which is a very big expensive mistake that I want you to fall in. Then after winding, then we are going to slot in, starting from the first run to the last run of the 2 sides. Then we put in our run, and then we call it a day. So after putting in the first one, then we're heading to the second one, which will be from 1, 2, 3, 4, 5, 6. So the second one is 1 to 6. The first one was 1 to 4. The second one is 1 to 6. Then the third one is 1 to 8. The fourth one is 1 to 10. Okay, so the difference is 2, but it is jumping in the 4 slots for the running coil. No, sorry, for the starting coil. Then immediately after that, we are going to head on how we put in the paper, but you can use a stick in order not to damage the wire coil. Okay, so this is 1 to 6 right there, and insulate it with the cover. Then what I didn't put in this video was stick enclosing or the wedging. I did not wedge this in camera, but when it comes to winding up the video during testing, you will be able to see some sticks within my stator. So those sticks help to keep the coil in one place, or even when the motor is vibrating, the number of turns or the turns do not vibrate, which may cause a chaos if at all not wedged properly. But I was able to wedge it, and you will be able to see at the end of the video. So please stay tuned, don't end or quit the video before we finish it up. I don't want you to lose up anything, and more tips are coming in depending on which stage I'm on and what we are doing. Okay, so I think everyone will sing here. However, the stator was too small for the hand and the camera to clearly observe, but more big stators are going to be uploaded, because I was looking at uploading a stator of 95 horsepower, but I thought of, no, people may think, how about the small ones? And when you're beginning up, you will start by these small ones. So why do I go for the big ones first? Because those ones are very, very simple. They are easy to make, so to rewind. So let's first finish up this small one, and then we finish up with those big ones. Then when you're slotting in the last here, you usually use a stick or a plastic, or anything that will not damage your coil. The same way I'm doing it here with a stick. Please don't use a metal or any sharp object which will damage your coils, and you end up into the other big mistake. So that is the last one in, which makes the fourth coil in the run coils. So when I make the 4 bottom, I'll have to make the 4 upper ones. Then my connection will not be too much, because I did not break the wire into 2. But if I had broken the wire, I was going to load the top. That is the connection that I was going to use if at all I had broken the wire. But I didn't break the wire, so I'm going to use a connection of bottom. So few can tell about that. But if you have any question, please put it in the comment section below. I'll be in a position to answer you, and we move at the call. Then after that, organize your coils so that you can create space for the starting coil to fit in clearly. Then we shift in the other side to put in the running coil, as I've started in already here. That is the running coil. Then this is the running coil. This is the starting coil, which will fit in the other 4 after putting on the running coil down here. So when I finish this, directly let's go on how to tie. So when we're tying, before tying, you have to first connect, because I've already tied the bottom part. So I'm only winding up with this upper part where connections are. Set your multimeter in continuity position, then test the wires to confirm that there is no short circuiting. So when you connect it, it will bring in the red light to show you that continuity is free with a given code. That will be either 20, 18, 17, no matter. But what it shows you that the resistance within the coil is 14. Okay, so that is okay. Then after that, cut the paper insulator and feed in the wires, because sometimes you find it that when the motor is getting burnt, some coils remain unburnt. So if at all you do it this way, you may have that chance to only slot in the starting coils or only the running coils. If at all the client or there is no time to put it in all, then that saves time, okay, and again money as well, because when you slot in only the starting coils, less money will be used. But when you go about it all, yeah, more money, because more materials, more time and everything. So insulate it like that. And again, when the running coil gets hit, it does not transfuse it into the running, which is also an advantage. So please paper it out. Then when we start tying, after, because I've already tied the bottom part, but please, if you have these nuts, you put them on, because we don't want to rest the wires, the winded wires direct to the ground. So please, that's why you are seeing those 3 bolts. I left them there to guide my motor upraised, not to touch the floor, okay. Yeah, then we're going to put our wires out, as you're seeing here, 4 of them, the 2 start and the 2 running, because this is a single phase motor with a permanent splitter winding program and the running capacitor. Sorry, I didn't talk about the running capacitor, but the running capacitor that I'm going to use is 20. So, and we're going to connect it at the end and everything will be working. Now, reducing on the size of this tying rope, because it was too wide. As you can see down here, it's already done and we are good to go. Then let's turn up here, okay, easily, and then we finish up the thing. It is not a very big issue when you're winding up, and when you're free, in your free time, you can even please try it out. So I'll need such comments like, hi, I get it. So when you get it, and remember, motor winding is a very active project, because in every machine or factories or around you, things around you, they all use electricity, and they turn that electricity into a useful thing in our surrounding just because of these motors. So speeding up here, you see that I'm going about it easily, because it is only the way of tying it around. I hate jumping too, because you sometimes miss out a given clue, but when I speed up here, you're able to see what went on and how it came up, okay. Yeah, then as we finish up here, we're going to varnish our motor, but sometimes I always recommend you to first check, because when you tie it properly, you wedge, you are able and you are free to first to test. But if you sure enough, like as I do, I just go straight and varnish and then test afterwards. Sometimes I don't do even the testing, because I'm sure of what has been done. But if you first time to do it, please first test before vanishing, because when you test before vanishing, it is always easy for you to uninstall these wires and recorrect the mistake if at all it is there. Then putting in the guards on sides prevents that maybe when the coil gets hit, expands, it does not touch the frame, which gives in more lifespan to the motor. So if you're doing as I do, then let's put it in the varnish. Then from the varnish, please rest it on somewhere, because the varnish may still leak and we don't want it to touch the ground. Then after that, we are going to assemble. Yeah, right now back here, our varnish is dry. Rotor cover, checking the bearings before putting it in has been done, and the bearings are okay, can run for the next few years. So we are going to still reuse these bearings, reusing the shaft, reusing the rotor, then assembling is done. But of course, dismantling this motor, I didn't show the video to you, but once you were with me from the start to the end here, you are able to tell that this is how to dismantle. So when you assembling, automatically you can dismantle. There is no way how you can do the assembling without dismantling. So when you see how I am assembling here, you are able also to dismantle a 1 horsepower motor, right? Okay, then finishing up here, we are going to test. Why I'm testing is because some people are stubborn. Some gents, ladies, gents are stubborn. One may ask me, how stubborn are they? That they sometimes comment and say, no, nothing worked out. Why don't you show us how it worked? Or why didn't you finish the video? Let's say the video is incomplete. So let me make this video complete by connecting first and testing. So after tying, please check by hand and see whether the rotor is freely rotating. And when you confirm that, then get your capacitor. As I told you that the capacitor is 20 microfarad or 200 farads. That's what you can say. That is 20 microfarads at 5% plus or minus 5%, which is a 220 volt. No, it is usually 450 volt. Yeah, right, 450 volts. So the connection is run coil to the capacitor, then power the capacitor from the junction, again from the power to the run. Then the neutral goes to the starting coil. Then after that, let's go and put in the power. So we are now going to end the video. This is the last point. So please take caution, see if at all there is anywhere where you didn't understand, or even the action. So here the motor is spinning. I'm pausing it so that you can realize spinning. Pause it again. Spinning. Because if at all I just spin it there, you can't easily realize by camera that the motor is spinning. But when I pause and start, yeah, you really tell that the motor is spinning. You see that? The motor is spinning. You see that? The motor is spinning. So that was the video of the day. Please don't relax, okay? You can do more research to top on that, which I'm sharing with you. You go in the box, find out more that was not so clear, then we make more things to work, even if not thought to. Bye bye.